This is Dr. P. Srilatha, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. In this session, I am going to discuss about Poisson distribution. What is Poisson distribution? The Poisson distribution can be obtained by binomial distribution under the following three conditions. First one is n tends to infinity. And second one is p tends to 0. Third one is np equal to lambda. So, the Poisson distribution can be obtained by the binomial distribution by the following three conditions. First one is n is very large. That is nothing but n tends to infinity. P is very small. That is nothing but p tends to 0. So, lambda is a finite value. So, that is nothing but np equal to lambda. So, by using these three conditions, binomial distribution can be converted into Poisson distribution. So, under the following conditions, the binomial distribution b of x comma n comma p. So, that is nothing but p of x equal to x, that is equal to ncx, p power x, q power n minus x for all x equal to 0, 1, 2, 3 and so on n tends to Poisson distribution. So that is f of x comma lambda equal to p of x equal to x, that is equal to e power minus lambda, lambda power x by x factorial for all x equal to 0 to infinity, because here we have n and here we have infinity. So by the first condition, n tends to 0, n is very large, right? So, from the following conditions, the binomial distribution can be converted into Poisson distribution. The binomial distribution tends to Poisson distribution. The Poisson distribution formula is f of x comma lambda equal to, that is nothing but p of x equal to x, that is equal to e power minus lambda, lambda power x by x factorial. So, where x equal to 0 to infinity. 0 to infinity. Theorem. So, this is very important theorem. Most important theorem. The Poisson distribution is a limiting case of binomial distribution. The Poisson distribution is a limiting case of binomial distribution. The definition of binomial distribution is, all of you know that b of x comma n comma p, that is equal to p of x equal to x, that is equal to ncx, p power x, q power n minus x. In binomial distribution, x is from 0 to n. X is from 0 to n. Okay, so we know that p of x equal to, x, so that is equal to ncx, p power x, q power n minus x. So, we know that ncx can be written as n factorial by n minus x factorial into x factorial. So, ncx can be written as n factorial by n minus x factorial into x factorial. So, that's why here I am taking ncx can be written as n factorial by n minus x factorial into x factorial. So, p power x and q power n minus x. And n factorial can be written as, so n factorial can be written as n into n minus 1 into n minus 2 and so on n minus x minus 1 into n minus x factorial, okay. So, here I am taking n factorial can be written as n into n minus 1 into n minus 2 into and so on into n minus x minus 1 into n minus x factorial. So, here n minus x factorial get cancelled. Okay. So, that is n minus x factorial into x factorial p power x, q power n minus x. So, here n minus x factorial get cancelled. So, we will get only n into n minus 1 into n minus 2 and so on n minus x minus 1 divided by x factorial into p power x, q power n minus x. So, that is n into n minus 1 into n minus 2 and so on n minus x minus 1 into, that is not factorial, n minus x minus 1 divided by x factorial into p power x q power n minus x. Now let us consider, np equal to lambda. So here I am using the three conditions of Poisson distribution. Okay, so first one is n tends to infinity, second condition is p tends to 0, and the third condition is np equal to lambda. So here I am using the third condition, np equal to lambda. Okay, so from that, if I take np equal to lambda, from that p equal to, we can write lambda by n, p equal to lambda by n. So what about q? So we know that p plus q equal to 1, from that q equal to 1 minus p. So 1 minus, we know that p equal to, so lambda by n. So lambda by n. So that's why this is 1 minus p. P is nothing but lambda by n. So q equal to 1 minus lambda by n. So substitute these values here. We'll get, so n into n minus 1 into n minus 2 into n minus x minus 1. That is not factorial. N minus x minus 1 divided by x factorial into p. So p means we know that is lambda by n. So lambda by n whole power x. Whole power x is there. Whole power x. And q is nothing but 1 minus lambda by n. So that is 1 minus lambda by n whole power n minus x. Whole power n minus x. Right? So now, so here I am taking lambda power x and x factorial outside of outside of this one. Okay. So here I am taking lambda power x and x factorial outside. So lambda power x divided by x factorial equal to, the remaining terms are n into n minus 1 into n minus 2 and so on, n minus x minus 1. Okay, so n into n minus 1 into n minus 2 and so on, n minus x minus 1, that is not factorial, n minus x minus 1 divided by, here we have, so already we have taken lambda power x, right? So here we have, the remaining term is n power x. So n power x, here I am writing n power x. Okay, so into, so next term is 1 minus lambda by n whole power n minus x. 1 minus lambda by n whole power x. Okay, so and n power x can be written as, so here we have n power x now. So now n power x can be written as n into and so on, n up to x times. So what is the meaning of n power x? N into and so on, n up to x times. So like that, here I am writing after this step lambda power x by x factorial into n minus 1 into n minus 2 and so on, n minus x minus 1. N minus x minus 1 divided by, so n power x can be written as n into and so on, n up to x times. So into, the remaining term is 1 minus lambda by n whole power n minus x. Okay, so separate the terms. Okay, so this is n by n into n minus 1 by n, n minus 1 by n, next one is n minus 2 by n, n minus 2 by n, and so on, n minus x minus 1 divided by n. N minus x minus 1 divided by n into, the remaining term is 1 minus lambda by n whole power x. So here we know that n by n is 1 into, so n minus 1 divided by n, that is nothing but 1 minus 1 by n, right? Okay, so and the next term is here, so n minus 2 by n, so that is 1 minus 2 by n. So 1 into 1 minus 1 by n into 1 minus 2 by n and so on into, so n minus x minus 1 divided by n can be written as 1 minus x minus 1 by n. Okay, so close the bracket. So here we have a lambda power x by x factor in the starting. Okay. that is equal to, so the remaining term is 1 minus lambda by n whole power n minus x. So we have to write, so lambda power x by x factorial into, that is 1 into this one only. So this one I am writing here. So that is 1 into 1 minus 1 by n into 1 minus 2 by n and so on, 1 minus x minus 1 by n into, so here we have 1 minus lambda by n whole power n minus x. So here we have 1 minus lambda by n whole power n minus x. Okay, so this can be written as 1 minus lambda by n whole power n divided by minus x. Okay, so 1 minus lambda by n whole power x. So, okay, so that's why I am writing here 1 minus lambda by n whole power n divided by 1 minus lambda by n whole power x. Okay, so this can be written as like that. Okay, so next I am choosing, next I am taking the first condition. The first condition of the Poisson distribution. What is our first condition? We have 3 conditions. If n is very large, that is nothing but n tends to infinity, p is very small, p tends to 0, and the third condition is np equal to lambda. So first I have taken this one, that is np equal to lambda. Now I am taking n tends to infinity. So now we have to take n tends to infinity. So limit n tends to infinity apply to this total term. Okay, so limit n tends to infinity into lambda power x by x factorial into 1 minus 1 by n, 1 minus 2 by n and so on into 1 minus x minus 1 by n into 1 minus lambda by n whole power n divided by 1 minus lambda by n whole power x. Okay, so if I apply here, limit n tends to infinity is there. So that's why I am keeping lambda power x by x factorial outside of the limit. Outside of the limit. So lambda power x by x factorial into limit n tends to infinity. So limit n tends to infinity. So if I substitute n tends to infinity, 1 into, this is 1 into, I am doing for this one. So 1 into, so this is 1 by 1 minus, next term is 1 minus 1 by n. N is nothing but here infinity. So we know that 1 by infinity is 0. 1 by infinity is 0. So 1 minus 0 is there. That is nothing but 1. So like that, here we have 1 minus 2 by infinity. So 1 minus 2 by infinity is, that is 1 minus 0. That is nothing but 1. Okay, and so on. So here we have 1 minus x minus 1 by infinity. So that is nothing but 1 minus 0. That is nothing but 1. That means this is 1 into 1 into 1 into and so on 1, right? So see here. So observe carefully. So here we have 1 minus lambda by infinity, but here we have whole power infinity. So we can't do this one. So that's why we have to write as it easily. That is 1 minus lambda by n whole power n. Okay, so observe here. For this case, 1 minus lambda by infinity whole power x. So that is 1 by 1 minus 0 whole power x. So that is nothing but 1 power x. That is nothing but 1, right? So this is also 1. So that means this total term is 1 along with this term is also 1, right? So remaining term is 1 minus lambda by n whole power n. So limit n tends to infinity into limit n tends to infinity. The remaining term is 1 minus lambda by n whole power n. 1 minus lambda by n whole power n. Okay. So now coming to this step. So lambda power x by x factorial limit n tends to infinity 1 minus lambda by n whole power n. So here I am taking n multiply with. So here I am taking minus lambda and minus lambda. So that means multiply with minus. So here I am multiplying with minus lambda and dividing with minus lambda. So now this will be converted to lambda per x by x factorial into, so limit n tends to infinity. See, so this is 1 plus 1 by n by minus lambda, right? So 1 plus 1 by n by minus lambda whole power n by minus lambda into minus lambda. So that means, so if I take limit n tends to infinity or n by minus lambda tends to infinity, that will be 1 plus 1 by n by minus lambda whole power n by minus lambda into minus lambda, right? So now which will be in the form of limit x tends to infinity 1 plus 1 by x whole power x. Okay, so limit x tends to infinity 1 plus 1 by x whole power x, that is nothing but e. So here we have formula, that is limit x tends to infinity 1 plus 1 by x whole power x equal to e. So now which will be in the form of limit x tends to infinity 1 plus 1 by x whole power x up to here. Which will be in the form of limit x tends to infinity 1 plus 1 by x whole power x. So now this is nothing but e, right? So lambda power x by x factorial into limit n tends. So this total term is nothing but here up to here, that is e. So that's why this is limit lambda power x by x factorial into e power, here we have minus lambda, right? Okay, so lambda power x by x factorial into e power minus lambda. So that means e power minus lambda into lambda power x by x factorial. So what is our Poisson distribution formula? The Poisson distribution formula is f of x comma lambda, that is equal to p of x equal to x, that is equal to e power minus lambda into lambda power x by x factorial. So this will be came from this formula, right? So what about this formula? This is nothing but binomial distribution. This is nothing but binomial distribution. That means the Poisson distribution is a limiting case of binomial distribution. The Poisson distribution is the limiting case of binomial distribution. So NCX, P power x, Q power n minus x. Okay. So the Poisson distribution is the limiting case of binomial distribution under the three conditions, that is np equal to lambda and n tends to infinity, p tends to 0. Here n is very large, p is very small, and np equal to lambda. Lambda is a finite value. Okay. Next, note, the total probability in Poisson distribution is unity. So we have to prove that the total probability in Poisson distribution is unity. So what is the total probability? We know that summation f of x equal to, we need to prove that is equal to 1. So here the total probability of the Poisson distribution, here f of x is nothing but, what is the Poisson distribution formula? So that is e power minus lambda, lambda power x by x factorial equal to, we have to prove that is equal to 1. Okay, so by the definition of Poisson distribution, f of x comma lambda, that is nothing but p of x equal to x, that is nothing but f of x equal to, what about the formula here? The Poisson distribution formula is e power minus lambda, lambda power x by x factorial. For all x is from 0 to infinity. So we have to take, so actually the formula is summation x equal to 0 to n f of x. But here we have to take in the Poisson distribution, x is from 0 to infinity. So x is from 0 to infinity, f of x equal to, we have to prove this is equal to 1. So we have to prove summation f of x equal to 1. So summation of f of x equal to, that is nothing but, in Poisson distribution the formula is x is from 0 to infinity, f of x is here e power minus lambda, lambda power x by x factorial. Okay, so here I am keeping e power minus lambda outside of the summation. So e power minus lambda into summation x equal to 0 to infinity, lambda power x by x factorial. Okay, so here I am keeping e power minus lambda outside, and the remaining terms are summation x equal to 0 to infinity, e power lambda power x by x factorial. So now we have to substitute x equal to 0, 1, 2, 3 and so on up to infinity here. Okay, so now let us substitute. So here we have, this is e power minus lambda into summation x equal to 0 to infinity. So lambda power x by x factorial is there. So this is our before step. Okay, so now we have to substitute first x equal to 0. So now I am substituting x equal to 0 here in this summation. So lambda power x by x factorial. That means if I substitute x equal to 0, so that will be lambda power 0 by 0 factorial. Okay, so now I am writing here, next step is, so e power minus lambda into, so first I am substituting lambda equal to 0. So that is lambda power 0, sorry, x equal to 0. That is lambda power 0 by 0 factorial plus, next I am substituting x equal to 1. So that means lambda power 1 by 1 factorial. So summation is there. That's why we need to put summation symbol, that is plus symbol. After that x equal to 2. So substitute x equal to 2 here. That will be lambda power 2 by 2 factorial. Lambda power 2 by 2 factorial plus, next I am substituting x equal to 3. So that's why that is lambda power 3 by 3 factorial plus and so on. So now this can be written as lambda power 0 is 1 and 0 factorial is also 1. Right? So that is 1 plus lambda by 1 factorial plus lambda square by 2 factorial plus lambda cube by 3 factorial plus and so on. So we have a formula for e power x. So what is the e power x formula? So that is 1 plus, so e power x formula is 1 plus x square by 2 factorial plus x cube by 3 factorial plus x power 4 by 4 factorial plus and so on. So now which will be in the form of like that only. So this is 1 plus lambda. So now which will be in the form of 1 plus lambda square by 2 factorial plus lambda cube by 3 factorial and plus and so on. So we know that 1 plus x square by 2 factorial plus x cube by 3 factorial plus x 4 by 4 factorial plus and so on is nothing but e power x. So here we have, instead of x we have lambda, so that's why that is 1 plus lambda square by 2 factorial plus lambda cube by 3 factorial plus and so on is nothing but e power lambda. So e power minus lambda is there and this is nothing but e power lambda, right? So e power minus lambda, so that is nothing but 1. So therefore the total probability in the Poisson distribution, is 1. That is nothing but unity. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.